Hello and welcome to this lecture on parameterized or overloaded constructors. Now a constructor is a method-like code that gets automatically executed during object creation. Now in a class it's not necessary that we need to write a constructor because one is given automatically. However, lot of times we would like to initialize an object with some values of our choice. Different objects with different values. An overloaded constructor provides the users a more than one way to create an initialized object. So we will have more flexibility. So at the end of this video, you should be able to define overloading of constructors, list the rules to follow while writing overloaded constructors, describe some of the best practices related to constructors. Let's recap overloading. Now overloading of methods means that one method, different signatures. So a signature basically means name of the function as well as arguments. The arguments may vary based on the number of arguments, the data type of arguments, the order in which they are placed, and all these stuff. Constructor is a method-like block that gets automatically executed during object creation, has the same name as the class, but there is no return type. So it is not really a function and you can't invoke that. It's invoked during object creation. Here is an example of a constructor. A class employee has a constructor employee. There is no return type, some initialization. A constructor without parameter is known as default constructor. If you don't provide one, a compiler automatically provides one, and this is called as an implicit default constructor. A class can have more than one constructor, but you have to keep certain points in mind. There can be constructor without parameters, which is a default. There can be constructors with parameters. Now you must ensure that the combination of data type, count, and order of parameters, they're all different for each of the constructors. Anyway, the name of the constructor is always the same, so the signature here corresponds to the parameters. Let's see a practical use case. Having more than one constructor allows us to create different objects in different ways. For example, here is a new employee. So all the values are defaults, ID, name, salary, everything is default. But we can supply a name. We can also supply an ID and a name. We can supply ID, name, department. What about ID, name, department, salary, or ID, name and salary? Now you can see we have different ways of initialization. Now if we do not have this flexibility, then we are limited to create an object like the first one and then set individual values using setters. And that would be equivalent to calling 4 or 5 different functions. This simplifies the task. So some usage. While creating an object, only one constructor is used. Here is an example. We have a class employee and a variable Shyam. We initialize one time by using new employee and another time by saying new employee of Shyam. Now you may be thinking that okay, we are able to call it twice. Now you can call n number of times. It doesn't matter. But every time you are calling the new and employee constructor, a new object gets created, because of which the previously created object, they are now not reachable or they are garbage. So they will be removed from the memory over a period of time. So for a given object, only one constructor is associated. Now for each of those objects, only one constructor is called. So how do we call a constructor? Now remember, constructors are automatically called during object creation. So calling a constructor using a reference like as in a method will result in compilation error. For example, Shyam is a reference of employee pointing to an object, and now you are trying to say let's reinitialize the name and say Shyam.employee of Shyam. Now this would be an error because employee is not a method. Now in languages like C++, you cannot even have a method with this name. However, in Java, it is possible that you can have a method with the name of employee. Now But of course, you'll have to say that it is a void or int or something like that as a return type. However, it is a bad practice to do. Now, tools like Eclipse, they will even suggest that, hey, you are using a class name or a constructor name for a method. Are you intending to give a constructor? Anyways, it's a bad practice. However, call to a constructor can be made from within another constructor. Now, this can be done with the help of the keyword this, as if you are calling a function called this. It looks for a corresponding parameterized constructor depending on whether such parameterized constructor exists or not. Now, here is an example. So, there is a class employee. There are two constructors. The first constructor does not take any parameter, but it calls this with two values. There is a ++ ID counter and there is 45,000. Now, this here means that I want to supply to another constructor. So, the keyword this will now look for any other constructor that has two parameters, first one being int, the second one being double, and the second one is found right there itself. And the control will be passed, that execution happens, and then it will come back and continue. There is nothing else to continue, the employee constructor is over. So, some of the points to remember at this point: having more than one constructor allows flexible ways of creating objects. So, you get a lot of choices to create an object. Having a default no argument constructor is always considered as a best practice. But if you really don't want to create, then you don't have to, because there are some API classes, for example, a class called cookie that takes two strings as arguments, and that is the only constructor that is available, which means if at all you want to create a cookie object, you have to supply two strings. Now, make the constructors public. This is not mandatory. Now, there are some concepts you will come over a period of time, such as, for example, singleton. They require a constructor to be private. Now, there are built-in classes such as java.lang.math, java.lang.system, java.lang.class. Now, there are some of them where constructors are private. Let's quickly summarize what we have learned so far. Now, overload the constructors in a class when you really want to provide more flexible ways to create and initialize objects of that class. Having no argument constructor is always a good practice. Constructors are generally made public.